Welcome to the Explainer. Okay, today we're diving into the critical mechanics of Salesforce integrations. Specifically, we're demystifying the essential non-functional requirements you really need to master for the request and reply pattern. You know, it's just so easy to get totally lost in the code, but today we are focusing on the architectural foundations that keep your systems intact. Okay, let's dive into this.
So, here's our roadmap for today. First, the integration stakes. Then, Pillar 1, error handling. After that, Pillar 2, security considerations. And finally, Pillar 3, the middleware matrix. Let's start with what actually happens when things go wrong.
Section 1. The integration stakes. Chaos versus control.
You know, it's incredibly easy to think of integrations as just these simple, passive data pipes, right? But imagine what happens when those pipes actually break. We're talking duplicate orders, hack systems, utter chaos. Picture this, you build an integration, but it's unsecured. Suddenly, some external system grants access to an anonymous user who has absolutely nothing to do with Salesforce, and boom, a massive wave of random orders starts hitting your production system for customers who never even asked for them. It's an absolute nightmare, massive operational headaches, and a severe financial drain. That right there is exactly why we have to integrate with extreme caution.
Which brings us right into Pillar 1, mastering error handling.
Listen, the golden rule of integration architecture is this. Connections will fail. It's inevitable. Networks drop, data gets corrupted, servers just go offline. So you really have to ask yourself, when an API crashes, whose problem is it? Say Salesforce is pulling payment info from an SAP API, and right in the middle of it all, that SAP API goes down for routine maintenance, the connection just drops. Does SAP have to figure out how to notify Salesforce, or is it your problem?
While the rule is super simple, the caller is entirely responsible. In our little scenario, Salesforce, or your Apex code, is the caller. So it's on you to handle the error. The receiver, like that SAP system, not their problem. It's honestly exactly like a dropped phone call. If you dial up a friend and the line suddenly goes dead, it's not your friend's job to hunt you down, right? It's your job as the person who dialed to realize the call dropped and figure out what to do next.
So let's see how this actually builds into proper transaction recovery, specifically for synchronous operations. Step 1, you send order 123 out to the external system. Step 2, you wait. You absolutely must wait for the order number response from that external system. And step 3, only after you receive that response do you actually save the data in Salesforce. The takeaway here is absolutely crucial. Never, ever save your data prematurely. Because if you save before getting that response and the external system actually failed, well, you might end up resending the request. Next thing you know, you've got these duplicate ghost orders just floating around different systems. You got to keep your data perfectly clean.
Now we shift gears from system reliability to business safety. Pillar 2, securing your integrations.
Okay, so we know how to prevent data duplication, but what about unauthorized access? How do we make sure our data payloads aren't being messed with in transit? Out of the box, Salesforce enables one-way SSL by default. But as an architect, you have to know that one-way SSL just isn't going to cut it for real security. What's highly recommended instead is two-way or bidirectional SSL. And alongside that, you really need to be using CA signed certificates to lock in the absolute authenticity of both the client and the server. Oh, and of course, those remote systems absolutely must be protected by proper firewall mechanisms.
Now pay attention to this, because it's a massive exam-ready trap. Salesforce does not support WS security. I really want to emphasize this because it's such a common conceptual blind spot. If you're designing an architecture out in the real world or sitting down for that integration architect certification, do not rely on WS security. Salesforce literally just ignores it right now. It's a super vital limitation to memorize.
So, since WS security is totally out, you might need to lean on some slightly geeky but incredibly vital tools instead. I'm talking about Apex crypto class methods. Whenever the requirement calls for it, you can use these methods to create one-way hashes or digital signatures. This gives you that critical extra layer of security, ensuring total data integrity. That way you know for sure your payload hasn't been tampered with while it was traveling between systems.
All right, let's move to our final section. Pillar 3, the middleware matrix.
More often than not, in big enterprise environments, you aren't going to be connecting systems directly point to point. Instead, you'll use a middle layer that sits securely between Salesforce and your external systems. Think platforms like Dell Boomi or Azure. Now picture this high-stakes scenario for a second. You're sitting in a job interview for a massive Salesforce Integration Architect role. The interviewer looks right at you across the table and says, okay, you're going to use middleware for a request and reply pattern. Tell me one mandatory requirement. Literally, your entire interview hinges on your next few words.
If you answer asynchronous transport, well, the interviewer is going to end the conversation right then and there. You simply cannot use asynchronous transport for a request and reply pattern. The right answer, the absolute mandatory requirement here, is a synchronous transport protocol. The big takeaway? Your choice of middleware can't just be blind guessing. It is strictly governed by the specific pattern you're trying to build. And this brilliantly illustrates the complete breakdown of those middleware features. Looking at the mandatory features for the request and reply pattern, we've got synchronous transport, like we just talked about, and event handling. Then we have the features that are, desirable. They're important, but they aren't strict requirements. Things like translation and transformation, mediation routing, and protocol conversion. Knowing exactly where to draw the line between what you absolutely must have and what's just nice to have, well, that's what actually makes you an architect.
As we wrap up this explainer, I want to leave you with a bit of a provocative question to chew on. Is your integration architecture truly ready for the real world? Like, can your code gracefully handle an unexpected API crash without accidentally duplicating a bunch of customer orders? Is it genuinely locked down with two-way SSL instead of just relying on the default settings? And is your middleware perfectly aligned with the synchronous demands of your specific patterns? I highly recommend you take these 3 pillars, hold them up against your own architectures, and test them rigorously. Because once you've truly mastered these foundations, you're going to be perfectly positioned to tackle external services and REST APIs next. Thanks so much for exploring this with me. Keep learning, keep building, and I will catch you in the next one.